Okay, a bit of a glitch there. We're going to do that one more time because you didn't get to see it. So here we go. 1, 2. Well, that's never happened before. I guess if I add myself between the intro part and or I guess the starting soon and the intro part, it takes over and then the intro part doesn't play. But yeah, anyways, there we go. Welcome to Innovation Coffee. Today is January 26th, at least in the Western part of the world. My name is Robert Wolf, and I'm your host this week and every week for Innovation Coffee, brought to you by ARM. Now, this particular live stream focuses on ARM developers and the things that ARM developers are doing around the world. During these live streams, we'll take a deeper look at this ecosystem. We'll look into different opportunities in the ARM world, and of course, bring different developer highlights or different developer developments, ARM developments, to light. Each of these events will finish with an audience Q&A. So if you have questions, save them to the end, or if you're just dying to ask our guests something, feel free to post them in the YouTube chat, and we'll do our best to bring them to our guest or us, your hosts, as soon as possible. Now, if you enjoy this live stream, please make sure you smash that like button, and don't forget to subscribe to the ARM Software Developers YouTube channel for more content like this. We go live every week at 5 p.m. UTC with this particular live stream, but we have lots of other cool content that gets published there quite frequently. So I think without further ado, I'd like to bring in my co-host first. We have Gabriel Peterson here. Welcome, Gabe. What's up?
Good morning. How are you doing?
Good. I'm trying to do all right. I was like, oh shoot. Okay, well, I was watching the YouTube thing over here. I realized that it wasn't playing the same thing that the StreamYard. I pull up my vape. I'm like, oh, I'm gonna hit this real quick before it starts. I got my breakfast, my little bowl of Takis here. I was thinking I was gonna grab one of those real quick, but nope, didn't get a chance. So, anyways, here we go. Let's get started today. In today's episode, we're gonna be meeting with Nikhil, and I'm gonna try to say your last name, Bhaskaran, the CEO, founder, I believe. We'll find out more in just a minute, of BrainyPi. And BrainyPi is a very awesome project that we picked up. Nikhil is one of our old ARM ambassadors, and now one of our old ARM innovators, and now I believe one of our ARM ambassadors. So we're going to bring him into the call now, learn more about Nick and the stuff he's doing with BrainyPi. I know Gabe has set up some questions, or Gabe has a few questions for him. I put some questions together. There's lots of cool things to explore here. Of course, anything we talk about during this episode, if you're watching it on demand, we'll be sure to share those resources in the description below. So go ahead, scope that out. If we say anything throughout the episode, you pretty much could scroll down and find that resource below. So here we go. Nick, welcome to the show. How are you, my friend?
Hi, I'm good. Thank you for having me.
Excellent. Welcome to Innovation Coffee. Thanks for joining. Yeah, I mean, where are you in the world right now?
India, right now.
India.
In Pune, India. Yeah.
So 9:30 p.m. right now.
10:35.
10:35. All right. Yeah. So it's late for you. Thank you for staying up late for us.
No problem at all.
Excellent. So the first thing we like to do in these shows, and I believe you've attended some of these before in the past, is get to know you. So, maybe you could spend a minute or two, tell us your origin story, like who are you? What did you do for the last 10 or 20 years? When did you get into industry? Where'd you go to school? Tell us some fun facts about yourself.
Okay. So quickly, I was always passionate about computers. Right in my engineering college, I used to play with computers, and most of the people have done that, creating different configurations, trying. And I think I always said in my college that computers are my first love and probably my only love, that I just love. I'm so fascinated by this device, everything around it, just insanely curious to learn. And everything that came around computers, I used to keep following. Every new configuration I would buy, every new phone that came in, I used to buy. And And those were those, we all been through that period of 2003 to say 2010, when a lot of things were happening in computers. Like it was like just growing exponentially. So many new things were happening. So been through that period, and then I was just surviving of the same business, consulting people on computers and all that. But then I decided to check out China, because someone told me that for the passion that you have, you should really check this like city, precisely Shenzhen. It is just too awesome there. And I said, maybe. Then I just bought a ticket and I went there, and oh my, that was like mind blowing place. And I would recommend anyone to just take a ticket if they have not been to Shenzhen. If you love electronics, it's concentrated dose of electronics, because Silicon Valley is also good for software, but it's not like in one place that it's in market form. It's in hardware. What happens is it's in market form. It is all computers in one market, CCTV in one market, security in another.
There
So
for you to like, you can see and touch it.
yeah, you can see and touch it, and you get like so many products, so many combinations of it. And maybe it's not something that the West would appreciate so much, but you can buy those designs. You can buy those design files right in the markets. And it's not. And it was like, I once bought the iPhone design files, and I was like, shit, I can learn so much. Something that I would have never got access to anywhere. So man, I just fell in love with the place. I didn't know how I would survive there, but I just thought I need to take a chance. And I went back home and said, hey mom, I'm just going to move to China for 6 months and see what happens. I don't know how it's going to go, but I just want to give this a shot. And 6 months became 8 years. I learned hardware design there. I became the community leader. Mozilla, I was selected by Mozilla also to represent the community in tech, because I was taking a lot of tech workshops and all that. So these two things always remain with me: tech and communities. Entrepreneurship is like by default. So China gave me too much insight into the product design and ecosystem, market and supply chain, why things get designed in a way they are, and all those problems of the products. And I cannot put all of that. That would need a separate interview. Uh, that what is this magic called China? It's a very different, and it's completely different culturally, the way things are done, the way the life moves in China, and the speed of the design, especially the speed of the design. Like whenever we had to design hardware, the targets on us were like, it was my own company, but the market demands were like, in a month you need to release your product out, otherwise don't submit the design. That's crazy, right? In a month you need to, because most of it is just incremental improvements. You have the previous designs and you're just optimizing it for price or adding a new feature that the market now needs. That's all design. So that's me in the hardware space. And then I thought that living in China, I really felt the real thing, like people who are serious about things must make both hardware and software in a way. If you want to get optimal performance, you need to work on the software. And much of my design experience was in ARM. I was doing TV board design there at that point, and then I moved to tablet PC. So I got a lot of exposure to ARM, and ARM was very fascinating for me. So I came back to India and I started this firmware company, trying to optimize the kernel and all those layers, because the same thing in China that I learned, products need to come out fast. How do we do that? So with that idea in mind, we came with Shunyas and made a lot of these ready blocks that people can assemble and go into a final product very fast. The idea was to do R&D for 3 years and then move to China and sell much of the thing. That was supposed to be in 2020, but 2020 is still not come. I'm still stuck in India. But yeah, that's the story so far. Yeah. So, and then after that comes BrainyPi, because we said purely pushing out software is very hard, because you need to really burn cash to make people adopt it and try it. If it's pure software, hardware is that people might just even take a chance on it and say, okay, let me try it. It works. So said, okay, let's not just put the software, let's give people hardware to try. And again, the same idea, there are just too many products that you can still build. And I think the West is way more creative, because they're closer to the customers, they understand the needs. But the amount of innovation that comes in software versus the amount of innovation that comes in hardware is very different, and somebody needs to work on that problem. There are a lot of good hardware ideas, that don't see the light of the day, and we've seen that in Kickstarter also. Yeah, so I think I
Yes.
don't know. Yeah, was
Well,
it? Mhm.
that's an awesome story. I mean, I like how you say 6 months in China turned into 8 years, somewhat unexpected. And then also you think about it, when you say, you love computers. I've talked to Gabe about this actually in the past, where I say, oh man, gosh, I really wish I was born more into the future, or I wish I was born like today so that I could see into the future. But then Gabe always comes back and says, yeah, I think we were born at the perfect time.
Yeah, if you were born too far into the future, the odds of you being tech savvy would be much lower because everything's so easy to use. It's
Low
not the
code, no
days
code.
like when we were first playing computer games and you had to actually worry about routing IRQ channels so that everything worked properly. And no game just worked out of the box. You always had to tinker with it before you could even play. And it's like that level of having to understand your machine is just not required nowadays, which is a good thing for most people.
Yeah, we talk, like we tell parents nowadays, like, oh, don't give your kids the iPad when they're so young. Don't give your kids the phone when they're so young. It's like, oh yeah, well, I had a computer when I was young. It's different. It's different. When you give a kid an iPad, they tap a game and it opens up. When you gave me a computer when I was like 5, 6, 7 years old, I had to like CD dot dot CD file this,
Right.
execute this, and you had to actually learn the file system. You had to learn how to use command line, and you had to actually put disks in and pop them out, and like he said, route IRQ channels and stuff. So it's like way different experience. Anyways, very cool, very cool story. Let's go right into the meat of the topic, or the meat of the episode here. And the main topic here is BrainyPi. And you kind of alluded to it right now, BrainyPi being a piece of hardware. And I want to post the website here real quick. So we have brainypi.com, and I'm going to post this in the comments on YouTube. It'll be available in the description if you're watching this on demand. What is BrainyPi? Let's start at the highest level. What is BrainyPi? Break it down as a company. Go.
Okay. So, I've published a blog just today, and it says bit.ly BrainyPi story. That explains it, but I'll just say it here. So, like I said, continuing from where I left it, there are too many creative people, way creative people who have wonderful ideas. And Raspberry Pi, without mentioning Raspberry Pi, they cannot be BrainyPi, because they are the first inspiration. They showed the world that so much is possible on hardware quick. The entire ecosystem is mind blowing. Hats off to those guys. And once you brought even the Arduino founder on innovation, and if you look, if you really think from their lens, they did such an awesome job of making hardware easy for people. And that led to so many new ideas. People still use them, and they have done so much DIY. So much came to the world just because of these two guys having a different idea. Now, but why should we stop there? And most of it is for prototyping, right? Why should we stop at prototyping? There might be great, wonderful ideas that can go into mass production, become full products. Now, Raspberry Pi does not release the Broadcom chip. That means you cannot redesign your product because the chip is not accessible. It's still a locked ecosystem. Though on the Arduino, you can do that, but at least on the Raspberry Pi, you can't. So BrainyPi is like taking that idea further. Everything that that entire ecosystem that Raspberry Pi built, we ported all those libraries, all that software, so you can still prototype as fast as you do on the Pi. In fact, the code directly runs on BrainyPi. That's the compatibility layer that we wrote. So that's a simple thing to do, though. But the idea is, now that you have prototype and you're getting enough traction in the market, you want to go to mass production. Yes, the chip design is available. We have the design files. We can work with you, take it to production, and slowly, eventually, this will all become open. There are issues with the chip company to just put it out all in open right now. They don't allow it. It's all under license. But eventually, things will get coming out open. So the idea is to open this new channel from prototyping to mass production. And that's why we were so, it took us a while to zero down on the chip, which we should keep. There's so many ARM SoCs with so many features, and then finally we picked RQ399. Because honestly, Google is a strong reason. The way they support that kernel on this chip, pretty stabilized, and they have an industrial version, and they also have an AI version pin to pin for the same chip. So like you said, you want to go into the future, so you have to think, yes, I need stability, but in the future there would be AI would be built in, and what happens at that time? What happens if someone wants to build an industrial product? And so how do we zero down on one chip which serves all this? So yeah, that's the story so far. The rest I can leave to you for questions.
Yeah. So, what did you see missing from other single board computers where you said, okay, I need to go and create my own? Like I can do something that other people can't. And I want to show them, like, what really separates the BrainyPi from other single board computers?
Thanks for that question. So you must have a purpose to exist, and that's what you're probably asking me. What is the purpose? Because there's so many SBCs and all of that. I think no one equals Raspberry Pi till date for the level of ecosystem support, all of that that they build around it, the community. Because you're not buying just a board, you're buying this entire community support and all of those software ecosystem that's built around it. Then I can say that there are these rest of the SBCs. I think most of them are generally just uh, there is something that Raspberry Pi created as a market. They are just taking a share of it. No one is building an ecosystem around that board. That's not the idea. Just take a share of that market, which is created probably with a little differentiation in terms of cost or slightly better configuration, adding few missing ports and all of that. But BrainyPi does not take that route at all. We're not planning to compete with Raspberry Pi. It has its own market for prototypers, and that's where it belongs, and it should belong there. Rest of the SBCs are competitors to them. We say, I mean, the purpose to exist is give people a stable board that you maintain for long term, probably for next 5-10 years. People continue to work on this board. So this is also building like Raspberry Pi. All the bugs are resolved, everything is resolved, and whatever you make, whatever you prototype on this, you can go to mass production. Now this one focus, you see other competitors have mostly China or Korea and all of these people, they have like 5 or 6 boards at different levels, different pricing, because their idea is to sell boards. The idea is not to create an ecosystem, versus we want to stick to one board. Though I have some question, I mean, like, because I see a segment problem there that some people cannot afford it. So there might be a second, but I'm not sure about it. But the idea is to not go and sell many boards or create many variety of. That's not the idea. The idea is to empower the ecosystem with a board with a lot of software done. So people only have to think of the application layer, build something real quick, and be able to launch a startup or a company on top of it. And ARM is still unexplored that way, I think, because so many people find hardware hard. So that is the primary purpose, that there can be too many hardware entrepreneurs who have not come out yet.
Okay.
That answer your question, Gabe?
Oh yeah, 100%.
So this raises a lot of questions for me. So you chose the RK3399, and I really do want you to walk us through the entire BrainyPi spec in just a second. This is a great thing, right? So when you talk about long-term support, the ability for someone to know that I'm going to start development on something today, it could take me 2, 3, 4, 5 years to finish that development, and maybe I still have 5 years to run it and profit from it as a company, right? And this is something that that was explored with the what was it? The 96 boards, Dragon Board 410C. So this was one of the first long-term supported boards from Qualcomm when they released it with 96 boards, and they were basically saying this is going to be supported for 10 years, and it was a great initiative. And so the reason for this was like, hey, just like I said, imagine I build something, but sometimes when you end up working with a board for like 2 years, next thing you know, your product's ready, and then that chipset is EOL, end of life, right?
Exactly.
So you've confirmed that the RK3399 is going to be around from Rockchip, right? It's Rockchip, right? Rockchip 3399, yes. That it will be around for 10 years, 15 years? Like, this is something you're sure of?
So this is Rockchip's promise, that Rockchip also maintains only this one chip for long term. That's their guarantee, that you can use it in all your industrial products. They'll maintain it long term. in case for any reason it changes, they would still have a pin-to-pin compatible chip. So that means nothing would change for you. Your designs would not have to change. All of that would not have to change because they still have two variants. There is one RK3399 with AI NPU built in, maintains the same thing, and then also an industrial version of the same chip, right? So they're going to maintain it. This is one of their core releases. So it is going to remain. And after all of that deliberation, we said yes, this is what is going to remain, and they have promised that they will otherwise provide a substitute which would have the same level of support and the quality, not like other boards or other chips that are coming from their stable, because they're consumer grade. That's why we did not take a higher configuration like a 3568 or a 3588, which is higher configuration and has more cores, but is a consumer grade chip, because they're going to last only 2 years, 3 years, and then they wouldn't remain in the market, right?
Yeah.
So
yeah.
that is, yeah.
No, it makes sense. And so I think it's perfect time here. Why don't you walk us through the BrainyPi spec? And what I can do in this case is I can pull this up over here. I can share my screen, present, share screen, window, and we can pull up have it right here. So walk us through this spec here.
Okay. So yeah, you can see it already. Yep. So yeah, on the form factor, it's exactly like the Pi, obviously, because for maintaining support with all the hats that Raspberry Pi has and the ecosystem, that's why it is this design. But the final product does not have to be this design. It can be any design that you want to. And what we changed again for stability, we added an eMMC to it. Okay, so when you deploy a product, or even if you do your trial runs, what happens is the SD card tends to fail a lot on field, and SD card issues lead to people losing trust on the board, and it slows down the whole thing. So we said at least give people a basic storage, so their application for most cases should be loaded on the eMMC itself. Okay, and that's 32 GB there built into it. And if people want to do more, they can connect SSD to this, and there's one more slot here at the SSD. So these are on the storage side, and on the CPU specifically, which we already said and a couple of times, it's 2 A72 cores and 4 A53 cores. So you can balance your application performance. If you want high performing cores, go for the A72. You want something simpler, keep it at A53, and you can balance because it does not then heat it up too much. It's all A72. And so these are the primary ones, and the RAM is currently between 2 and 4. We have two models. For the Android, 4 is required, but for Linux, 2 does fantastic. Okay. Then apart from that, I think the critical one is we have gigabit LAN port. We have USB 3, 2 of them, and then we have USB 2. The same form factor of CSI camera, and also you can connect an LCD screen, DSI. So these two remain, and then the 40-pin GPIO. So I think these are the critical ones, unless you want to know, obviously the HDMI is there, and we have a full HDMI because it's more on the Pi 3 form factor, because that's a more stable form factor. And then we don't have Bluetooth 5 for some reasons of supply chain shortage. So we have 4. Actually it's 4.2, but the driver is not only supposed 4.1. So the reason we did not take Bluetooth 5 is because it's used in most of the mobile phones, and there's a lot of demand for that Bluetooth 5, and that is why even Raspberry Pi is not able to bring out supply very quickly. There are some of those components. So while design, this is one of the things that we chose. Okay, we sacrificed 5, but this would remain, and at least the supply would not be a challenge on this chip. So otherwise is there. And then obviously we have Type C with supporting any voltage between 24. So industrial power to normal 5-volt power, you can plug in anything that you want.
This is great. Yeah. So it looks like a question came in the chat here. Could there be an 8 gigabyte or a 16 gigabyte memory version or RAM version? Because here it's looking like you have 1, 2, and 4 gigabyte optional. The comment is basically saying that 4 gigabytes seems too limiting.
Okay.
Is there ever going to be an option to upgrade that?
Now, because we will not, I think I'm not seeing enough demand for 8 So though this is possible on when if they have a custom order, that means if they want to produce a batch of 3,000 for themselves, they can get an 8. But for prototyping, probably they'll have to do it on 4, because that's all. I don't see enough market for. As the price goes up, people tend to not buy expensive ones to do their prototyping. So the market shrinks at higher price. For Linux, 8 is too much. I don't know what is the application they have in mind. I would like to really know. If it's server and all that, then making a cluster is a better thing. That each of them don't. The application itself, an 8 GB application is too big an application. I don't know what they're thinking, and there might be use cases which I'm not aware of. But largely, that's not the area I would like to go, because each one I produce, I need to produce a batch, right? I mean, these are SMT produced, so I need to buy a reel of it and produce so many pieces. So maybe if the market grows, and I'm sure, and there is a lot of demand, I don't mind doing an 8 GB also, 8 and 16 beyond. But right
Well,
now, not in
that's
plan.
good to that's good to know that it's possible, right? I mean, and that if there is a demand that comes up, then yeah, I know Hybrid Robotics. He's actually really into let's call it what is it? Automotive? No, robotics. There you go. Hybrid Robotics.
Yeah. Our primary
Robotics. Yes.
robotics is great because we have ROS people already running ROS and stuff on it. So I'm sure he must be thinking much more and knowing
Literally what
something.
he just said. Yeah, he's like, I'm working with robotics, and 8 GB RAM is my minimum RAM. It does not matter to me how much it costs. I need the RAM for stuff like ROS. Yeah.
Yeah, got it.
Yeah. All right.
So,
Cool.
so with these going over all those the specs, when you kind of created the spec, what did you have as the ideal use case for the BrainyPi, or what do you see as being the person who does this thing should get the BrainyPi?
Okay. So if you go to the website, we have divided the audience into 3 segments. We said there are the super experts and who try extremely niche ideas. And if you go down, it's like 3 audiences, So we said that the market is in 3 segments currently. There are these people who are prototyping, enterprises, community, no, not below that. So the prototypers, and then there are some niche customers who have extremely different requirements. We said this is a cream of the market that we would not be able to serve at this point. The bulk of the market remains in between, the professionals, makers, and super experts. If you come down, right, and we know some numbers from the market study at what price point the market has volume and at what price point the volume goes down. So for these super experts and all those niche areas where you have different requirements, the market is extremely small. And then the makers market is very big, but we don't want to go and compete with Raspberry Pi. They're doing already a fantastic job. So though we do support them, that's not our primary, but we are looking at the professionals market where people are building daily use products, kind of products that don't have extremely high requirement. It can be your home automation or a lot of other stuff that people can build for a daily use, can be on your farm, can be all that have a limited RAM requirement, or this serves them. So with that in mind, we chose to do this kind of configuration. Yeah.
So actually, this brings up a good point right here. So I guess two-sided question here. One is your intent with this board to put this board, like I buy the board, I build something on it, and then I put this board into the product? Or do you intend on building derivations of the board using that chipset to put into a product? And the reason I ask this is because, like, I'm curious, is your board certified? Like, have you gone through the process of getting this board certified with the FCC, CA, UKCA, ROHS, all of those different organizations to get it certified?
Yeah, good one. So the idea is that you prototype on this, and if you're going into mass production, redesign it, redesign the hardware for your form factor, whatever suits your product, shift it. Okay, that's the ideal scenario, but you can still use it in your product directly. If you have small volume, we already have finished our FCC, all of that, and ROS is okay, but other certifications we have not done. As we go in more and more into the market, we see where is the demand coming in, we'll complete those also. But primarily, yes, right now the idea is that people should prototype on this. and come back for mass production, like come for redesign, and then we work with them and redesign it for their exact use case. So that's how it is thought.
Excellent. Yeah, no, definitely. I mean, certifications are pricey, right? Like it's not something you should just jump on right away. I like the whole prototype derivation idea, right? Because then if you end up really, hitting a what is it? Hitting a niche market, and you end up finding, what you're selling, and you build something awesome. I mean, go get it certified yourself. Also, maybe you could save some money on the device itself. Like you don't need 4 USB ports for your product. Remove those, save some money. You don't need the low speed header anymore or whatever. I don't know. There's a lot of things you could save money on. So we have a question from David Walmroth here. GPU, question mark. How would the BrainyPi be on an autonomous robot running ML, object detection, etc.?
Okay, wonderful question. Now the GPU issue has a completely different problem. On Android, there's no problem. The drivers are okay, but Linux drivers are Mesa, and Mesa has its own limitations. Vulkan is not supported. Vulkan does not run smooth. We're still trying to get all that ported. OpenGL works, OpenCL works, but we have an entire AI team, because we were into developing AI libraries and all of that. And we are working on ARM-CL also. I mean, we are putting ARM-CL. We'll release at least 30 to 40 models, which work highly optimized using the Neon architecture. Just the Neon and the CPU, it should do fantastic for you if you're just inferencing, not for training. But inferencing will show you some real performance benchmarks that even without using GPU, you're getting awesome performance, because there's a lot of model porting and shifting it to Neon that is being done. And then in less than another 15-20 days, you'll see all these performance benchmarks getting released that on Neon. That actually ARM is still underexplored. Trust me, ARM, I don't know how to say this, but there is so much that an ARM CPU GPU I cannot say, but the CPU has so much power that is still not unlocked. There is so much that is not known to the world. Like what is under the hood in ARM-CL, it's not adopted enough. If you just go and explore ARM intrinsics, you would just write a program very differently. Once you know ARM intrinsics, it's so powerful. You can do so much without GPU. And if you go to Shunya OS, our website, we have shown something on a chip, which is RK3308, which does not have a GPU. And we released face detection, face recognition, and even WhatsApp, a server, all of it in that one SoC, which does not have GPU. And it's just a $9 SoC. So the power of ARM, and these are frames set by Intel and Nvidia, and nothing wrong, because that's how that everything needs a lot of compute, everything needs GPU for AI. Probably we just are not examining it from the technical point of view. Do we really need it for my application? So
we need you to be our spokesperson.
No, trust me, ARM has so much. I'm still not speaking about the servers and how but the only thing is you need to look at ARM very differently. You cannot look at it from the same paradigm that the previous computing generation set for you. If you look at it from a very different paradigm, that why should I need, like somebody said, I need 8 GB. Why should I run everything on one computer? Why can't I have two different computers, two modules, split it and run? Because you've gone in software, you've gone into Microsoft services, you've gone into Dockers. You're not now thinking it as, okay, one system needs to have it all. You're thinking it in containers. You're making different applications run that way. Why not do that same thing in hardware? Probably instead of making one large hardware, think of it like this, that you can put these small, cheaper ARM units and run each of them in separate, and you still can bundle them.
Okay,
yeah.
So Nick, let's. I'm sorry, Gabe. I know I told you to go next on this one, but this actually, I need to address this one right here. So you've been hinting at it. You've been talking about it. What is this? Is it this server, this cluster, this idea of having multiple computers? Weren't you doing? I feel like you were doing something like this previously, not too long ago when we spoke, like a few years ago. But I guess I'm curious. Okay, so you're saying instead of putting 8 gigabytes on this BrainyPi, just get 2 BrainyPis, cluster them together, and now you have 8 gigabytes. Like, why don't we think that way instead?
Right. Because
but are you are you offering a service like this, or are you just saying like, hey, BrainyPi can do this, and
no,
you
we
should
have
do it?
released some of the codes and all this clusters. So there's a team of 8 people working on optimizing clusters on BrainyPi, and this whole thing will show that high performance servers, if you cluster, you can still get the same amount of performance. We're doing a lot of performance testing, but primarily why? Software leads, like every challenge anywhere in management or anything, I think software leads the world. All those challenges, software is hitting the extremes of things. So at software, you face all those challenges and then they solve it. So how they solved it is by bringing in microservices. Otherwise, they could have just gone on expanding the software, and because there's so much to serve. But people thought the better way to do it is in microservices. So they split the software into microservices, and that's how you can talk to different applications. They run on their own levels. There's no complication. If it were in all one system, probably all the software would not even run.
I mean, it's no different than multi-threading, right? I mean, if you think about it in a way, so you multi-thread by splitting the cores and having these cores each perform their particular tasks. You could have multiple computers perform their independent tasks, or am I way off base there?
Somewhere, because it's still in line. HPCs did that in the past. That was what HPCs were doing, high performance computing and all this of even talking between computers, and all of that was there. But what essentially changed in microservices is they're isolated. A container is an isolated system. So the entire, it was all the Red Hat built these Linux systems on which you could install 10 applications. But then there were dependent libraries that were different, right? So then they created Docker, which is an isolated system, microservices running, not a monolith, right? That, because they face those challenges, there are so many dependencies, and you cannot have put all of that into one system. You need these isolated pieces of system. You need to update one differently, all of that. Now, if that is what they faced as a challenge, going forward, trust me, we would see where even in the robotic use case or anywhere, you might need an ARM, and for some reason you might need an Intel also. For some application, it might be an Intel. Why not create a hybrid system? And that is possible in cluster. When you cluster it, you can create different combinations. So you have to come out of this old paradigm and which is what a lot of people are coming to the ARM server business, but they're coming the exact Intel way. What they're doing is they're making this high performance CPUs with RAM, but that is all a different thing. Think different. You can be more flexible with ARM. Right? Think microservices. Think of small computers. If you want 60 cores, you use 10 small computers inside, and they can be different systems completely. And now you have the software layer which can manage all of that. Right?
Yeah.
Makes sense. And you can even build a hybrid computer there. That's the fun of it. That you can put an Intel in between those 10. You can have 2 of those Intel systems, because some of your applications run only on Intel. Right?
And not to veer off too much, but I was distracted by the website. I know at the very top you say available to select audiences and currently in beta. So the question I was getting from reading that is, what is that select audience you have in mind? Like, if someone wanted to participate in the beta, who are you looking for? And also, is there kind of a date you're shooting for to leave beta, to where the wider market can get their hands on one of these?
Okay, thanks for the question. So the first part, we look at 2 kind of people right now: influencers who will spread the word, and people who have an existing volume or like something that is in their pipeline for mass production, that they've built their prototype, or they are already deploying some devices in the market, because we would want that credibility that something is going in the market and it's a mass production hardware.
Right.
So influencers and people who have numbers right now, because also for other reason, we need numbers to continue to keep producing. We need numbers, so we're trying to secure those numbers. When would we go out of beta? Currently, the testers are reporting, there are very minor bugs, but there remain some bugs. And because when you send it across the world, you realize that some people have very restricted network environments, some things don't update. And we have because we have EMC, and many people find flashing an EMC very hard. So we have a recovery OS. which is like a mini, like a BIOS thing. I love the BIOS thing on the Intel computers, that you can just go and set everything, so we have all those boot from, where do you want to boot from, and it also installs the OS for you. You just go and do a network install. You just select inside the BIOS which OS I want to install, and it connects to the network, and it just boots. So all that is built. So the point being that primarily we look at these two audience, so people can come out fast and come into mass production after all these bugs. So we would go out of beta probably in March. The reason is I'm just waiting to get my visa to China, so I can also talk to the factory. How are we on the production? If you go out of beta and suddenly the demand spurs up, and how are we on the production dates and all of that. So and it's very hard to communicate with China. And though we did it for last 1 year, it's very hard to send all the files to talk, and without physically being there. So that's some of the issues. But otherwise, yes, as per plan right now, it should be out in March. Shouldn't be a problem. In fact, by Feb end we should be completely sorted, and March we should have enough so people can just buy.
Yeah, that's not far away at all.
What's the price point we're looking at here?
$75.
And that's for the 1 gigabyte, 2 gigabyte, 4 gigabyte?
2 gigabyte. We'll bring 4 at the same price as we hit volume. We'll bring 4 at the same price point eventually. Nice. But it has eMMC built in. So there's a cost for the eMMC built in.
Yeah, so it looks like we got a comment in here from David Tischler. You may be familiar with him from another ARM innovator back in the day. David Tischler says, I'm not sure that the Arcade 3399 can support 8 gigabytes of RAM. I think the max memory that SOC can address is 4 gigabytes. That needs to be fact-checked, but it's what I recall. So that may not be true, but he just brought that up to address Hybrid Robotics comment. And then we have another comment here from Hybrid Robotics saying, yes, I cannot use a board with less than 8 gigabytes of RAM for my robots. Robot operating system is too slow with less than 8 gigabytes. What do you think an 8 gigabyte version of BrainyPi would retail for? So I feel like that's too tough to answer.
Yeah, it's hard to answer with the current pricing component and all of that. A lot needs to be worked out. So yeah, I cannot comment on the pricing right now.
No, that makes sense.
There are many other things that go into a pricing thing. It's not just about the component pricing. There are many other things, like how many are you producing, what is the real size, and there's a lot that goes into pricing. In fact, if you go higher volumes, you can bring down the price and you can offer the same thing at same price. There shouldn't be a problem, because hardware is purely a factor of volume. It's not about your configuration. It's a factor of volume.
Yeah, agree. Cool. All right, let me see what else we got here. I know I had another question here lined up. Gabe, it looks like you have one or two more, or no?
Well, I kind of combined mine together. So all of my questions I had
all done
and introduced to him are taken.
No, that's all right. That's all right. So unless we have any more questions. Oh, did you want to say something, Nick? Go ahead.
Oh yeah. And there's this one point I don't want to lose the opportunity to bring it up.
Please.
We spoke about it on even on Discord and the last time, that trust me, is still it's a magic that's not discovered. There's so much that humanity needs that ARM already has, but people don't know. And on the servers and all of that, I think tech is always. Though I love tech, but I think it always is fascinating because it takes humanity to the next level. At every level, we have a new challenge, and tech needs to solve that challenge. Currently, our challenge is climate change. As we go into more and more digital transformation, if we remain the same old paradigm of more compute, more power, more data centers, all of that, we're going to consume humongous amount of power. And every day, the amount of people who surf all of those Insta shots and all of that, the amount of video that you consume, can you imagine? Like when we put together those computers, a GPU would be a different card. If you were to even stream this and do very high quality rendering, you would need another card to make your video decoding, encoding, all of that, and all of that is built into this tiny chip.
It's amazing.
Video processor, there's a GPU. You're not buying different cards for the full size of those cards that you would buy, and the compute and the power it would require. All of that is integrated into this chip, and very stable, very good encoding, decoding. So at this point, as the race, we face the challenge of, yes, digital, we cannot go back on it. We just need more and more digitization, and digital transformation is going to happen. But can we continue with the same hardware consuming so much power? Like on this one, we actually did a measurement. We put 66 cores of this. It consumes only 125 watts of power. Now take that against an Intel server. It would take the least it would take is around 800 to 1200 watts, in this range, depending on other cards. If you're not putting in the GPU and all of those cards, that means you're bringing down by at least 1/10 or more, or less. I mean, like in that range. So if that goes into all the data centers and you bring down so much power, your cooling, your carbon footprint is much lower. So I was discussing with a NGO here that for everything that we sell, for every server, in a way, where we sell, we plant equivalent amount of trees. This is possible only in ARM because the carbon footprint is so low. We can balance it out with trees and say that, okay, here is zero carbon footprint. Feel free about yourself, that no guilt. Whatever you're hosting on ARM is zero carbon footprint. So these are things that inspire me to go into this business. That yes, there are demands of the world right now that this technology can solve and is not known fully. Yeah.
And in comes David Tischler with that. That, by the way, beautiful, Nick. Beautiful statements. I love it. Yes, I mean, take it for what it's worth. Until you've explored ARM, you don't know. You don't know the impact you could make on the world. But yeah, no, I love that. And Nick, I mean, I couldn't have said it better. And then here comes David saying, this is the whole reason I'm passionate about ARM servers, energy savings versus x86 at data center scale. So yes, totally true. And now you can even find like ARM-based servers, Neoverse-based servers in AWS, Google, Oracle, all the big Microsoft, all the big cloud providers now have ARM-based servers too. And then here you have companies like BrainyPi bringing out your ability to, and let's say expediting your path to product by allowing you to get these types of boards and even cluster them and scale as much as you like. So with long-term support. So there's just a slew of benefits in all of this. And you got me all hyped up now. Like I feel like I need to go run around the block to burn off some energy. But yeah.
Sure. Some more support from ARM would help. Actually, we need to put out these things that ARM has, all these features, put out those numbers, make some more blogs, and there's so much about ARM that is still not known to the world.
Yeah, Robert, you'll probably know the exact number, but I remember when we were reading about Alibaba Cloud's energy saving claim. What was it, like 40% savings, something like that over x86?
Oh, it's like 40% savings, 20% increased performance, stuff like that. Yeah. I mean, in most cases, in a lot of cases, it really depends on the workload, right? So like, you can't tout it in every case, but it's workload dependent. But yeah, I mean, it's getting better every day. So in terms of
need a big fan, like on Intel, on even a basic processor on Pentium, you had this big fan.
No fans needed.
Yeah. On data center, cooling is a big energy consumption. Is not just the power the hardware consumes, but the cooling, the amount you spend on cooling.
Yeah. Oh yeah, no, I mean my computer here. This computer is not an ARM computer. It's for gaming, right? But I use it also to stream and stuff. Now, if I leave this computer on without any other, temperature modifying tools in my garage, this area of my garage turns into a freaking like sauna. Like it just starts to heat up so much. I get hot. And during the summer, you almost can't even be down here because this computer heats up the whole garage. It's crazy. But yeah. So anyways, Nick, we're getting to the top of the hour. Okay. As always, it is just an immense pleasure to hang out and talk with you. This is the time where we give you a shameless plug. And I feel that, you've already given ARM so many kind words. Let's talk more about BrainyPi or any other initiatives that you're a part of. I don't know what happened. I think that did we just crash?
Yeah, I got kicked out.
The whole thing crashed.
Yeah.
It's your Intel computer, right?
Yeah, I think StreamYard like literally crashed.
Oh,
Yeah.
okay.
Oh, Gabe, are you still there? Okay. Look, now Gabe's back. Gabe's back here as another person. Let's remove Gabe here. Bring him in. Gabe, you there?
Yeah, StreamYard is not having a good time at the moment.
StreamYard is having a bit of a hiccup today. That's all right though. So we still have time here. Nick, shameless plug on you.
So, what do you want?
Oh wow.
No, we lost.
We lost Nick. I don't know if he's going to come back. Okay. There, Nick's back. All right.
As
Well,
someone
this
else.
is interesting. Hey. How long can we go? Yeah.
So the microservices is not working well, so probably they're not scaling. All of this is kind of slow. The applications, if one of the containers crash, it should just spawn off another and just keep running. So
I know.
Yeah. There's something wrong on the architecture. I don't know what's not working.
Let's rush through this then. Let's go. Shameless plug, and I'll close this out.
Okay. So all we want to say is, yes, there is a lot of potential on ARM. BrainyPi is just going to show you how much can be done in terms of AI, in terms of servers, cluster servers. We are also building a streamer, so which people can just plug and play. Don't need a computer. You just plug anything into the HDMI and you start streaming wherever you want to stream, even in that size. So the thing is, we think we have seen enough of computers and we have kind of got bored about computers. No one's anymore excited about new configuration. But with BrainyPi, if it all goes our way, you will see surprises. You will start seeing so many new devices that are niche. They do one thing, but they do it so well that I think there are another 5,000 devices to be created doing different things, all of them smart and connected. So just keep a watch on us and support us. And I would say there's nothing about just throw in your ideas. I would like to really know what people want to build. All of these things, anything that impacts humanity especially, is something that's very close, because there should be a purpose for whatever we do. So if there is anything around green, anything around that impacts, say building low cost computers for even India or Africa or all of that, where you can build it using ARM, come up with those ideas, share it with us. We're very happy to support those kind of ideas. That's all I have for me.
Awesome. And go to brainypi.com. BrainyPNYPI.com. Gabe, what about you?
Yeah, so I just want to remind everyone that we have a subreddit, ARM Software Dev, essentially a place to post anything ARM related, projects you built, cool things you heard about, pretty much anything. So it would be great if anyone who's interested would make their way over and just join.
Nick, do you use Reddit, Nick?
Yeah, I do. I use Reddit.
You should go post your blog, your BrainyPi blog on there.
Yeah, sure. Okay. Here it's on you can post on the YouTube also.
We'll post that. Let's post the Reddit link on the YouTube too, so Nick can go over to the Reddit and post his blog over there. But yeah, cool. All right, I'm gonna close this out then. Nick, thank you so much for your time today. We love it. Everything was awesome. BrainyPi.com. Everyone go check that out. Gabe, thank you. Amazing co-host over here. And let's finish this off. So everyone, wonderful that you spent your hour with us and not doing something else, lame over there. You spent it here looking at, cool ARM stuff going on in the world with Nick from BrainyPi and Gabe and I. If you would like to join us again, we will be back next week and every week at 5 p.m. UTC. Check us out. Don't forget to also join our Discord server right here. It's discord.gg/ARM Software Dev. Lots of interesting stuff happening over there. And if you are a developer, I would highly recommend signing up to the ARM Developer Program. Go to arm.com/resources/developer-program. Join us there to get access to all sorts of amazing resources and join the community of other ARM developers. Now, breaching the thousands of members, lots of people. and things to learn about in that area. Of course, we make sure that all of our communities are equipped with ARM experts. So if you come in there with any questions, we hope to have an answer for you in a timely manner, help you get everything you need in terms of access to ARM technology and the resources you need to build on ARM. Excellent. Okay, let's share this one last time here as well. This is the blog we're talking about. It is bit.ly/BrainyPi story. Don't forget to check that out as well. This is the blog. Pretty much all the stuff that Nick talked about today. You can go read that there. And yeah, amazing. All right. If you like this video, make sure you hit that like button. Also, if you like more stuff like this, make sure you also go check us out or subscribe to our channel. Let's hit this end button. Okay, outro. Okay, bye everyone.
All right.
I talk too much. Okay, bye.